What's up everyone, and welcome back to Tech Curiosity Stream. If you're new, we dive deep into the tech that's shaping our world. Hit that subscribe button and ring the notification bell. Today, we're talking about something that sounds like science fiction, but it's very real: digital twins. Imagine a perfect virtual copy of a physical object or system, updated in real time. Test a jet engine without risk, test a treatment on a virtual heart. It's the ability to predict and optimize in a virtual space. It's a game changer with massive implications. We're going to unpack what digital twins are and why they're a significant technological shift. Let's explore this technology that is fundamentally changing everything. You've probably heard buzzwords like Metaverse, AI, and the Internet of Things. These technologies are interconnected, building on one another. A digital twin sits at the heart of this convergence. It uses data from IoT sensors and AI to create a virtual world mirroring our own. Before building a subway, a digital twin can simulate its impact. It's a living model to ask what-if questions. A digital twin represents what something is like right now and what it could be like in the future. This continuous flow of information allows it to evolve. Ultimately, this bridges the gap between the physical and digital worlds. Digital twins create a powerful two-way bridge for feedback and improvement. This connection makes this technology transformative. Now, you might be thinking, okay, this sounds cool, but what exactly is it? Let's break it down to its core. A digital twin is a virtual representation of a physical object or system that spans its entire life cycle. It's updated from real-time data and uses simulation, machine learning, and reasoning to help decision-making. That's the textbook definition, but let's make it simpler. Imagine you have a real physical car. Its digital twin would be a highly detailed virtual model of that exact car on a computer. But it's more than just a picture. This virtual car would be connected to the real car through sensors. When you drive the real car, the sensors measure everything: engine temperature, tire pressure, speed, fuel consumption, even the wear and tear on the brake pads. All of this information is sent to the digital twin in real time. So the virtual car on the screen isn't just a generic model. It's a living copy that reflects the exact state and condition of your physical car at that very moment. It ages, experiences stress, and performs just like its real-world counterpart. The real magic happens when you start interacting with this twin. Because it's a perfect digital replica, you can do things to it that you could never do to the real object. For a car manufacturer, they could run a simulation to see how your specific car's engine would perform over the next 50,000 miles based on your unique driving habits. They could predict when a part is likely to fail and alert you to get it serviced before it breaks down on the highway. This predictive power is what makes digital twins so revolutionary. So, in essence, a digital twin has three key parts. First, there's the physical object in the real world. Second, there's the virtual model in the digital world. And third, and most importantly, there's the connected data that flows between them. It's this constant two-way flow of information that makes the whole system work. Without the real-time data, it's just a model. Without the model, the data is just a bunch of numbers. Together they create a powerful tool for understanding, predicting, and optimizing the world around us. So what makes a digital twin and not just a 3D model? The key difference is life. A standard 3D model is static, a snapshot. It shows design, not real-world performance. A digital twin is dynamic, constantly evolving, fed by real-world data via sensors. This data ensures a true one-to-one digital reflection, mirroring wear, stress, and history. Imagine two new cars. With digital twins, each gets its own unique virtual counterpart. The digital twin becomes a personalized, historical record. It's not just a model of car, it's a model of car. This living link allows us to understand and interact with physical objects in previously impossible ways. A digital twin can be broken down into three essential components. The first pillar is the physical object itself. The second pillar is the virtual model, a detailed, high-fidelity representation. The third pillar is the data connection that ties the first two together. Data flows from the physical object to the virtual model via sensors. Information flows back from the virtual model to the physical world. Insights gained from analyzing the twin are used to make better decisions about the real object. It's this closed-loop system that makes a digital twin so much more than a simulation. Now, it's important to understand that not all digital twins are created equal. They exist on a spectrum ranging from relatively simple to mind-bogglingly complex. The level of detail and integration really depends on what the twin is being used for. At the most basic level, you have what's called a digital twin prototype. This is a twin created the physical product even exists. Engineers use these to design, test, and validate a product in a virtual environment before ever building a physical prototype, saving a ton of time and money in the process. Moving up the complexity ladder, you have the digital twin instance. This is what we've mostly been talking about. It's a virtual copy of a single, specific physical object that is currently in operation. Each instance is unique because it's tied to its one-of-a-kind physical counterpart. For example, an airline might have a digital twin instance for every single jet engine in its entire fleet. Each twin would track the specific flight hours, maintenance history, and performance data for its individual engine, allowing for highly customized and predictive maintenance schedules for each one. At the highest level of complexity, you have the digital twin aggregate. This is where things get really interesting. This type of twin brings together all the individual instance twins to create a functioning model of an entire system or a network of systems. Imagine not just having a twin for one wind turbine, but connecting the twins of every turbine in an entire wind farm. This aggregate twin could then simulate how the whole farm would perform under different weather conditions, or how shutting one turbine down for maintenance would affect the power output of the entire system. This aggregate approach can be scaled up even further. We're now seeing the development of digital twins for entire supply chains, factories, and even smart cities. A city's digital twin would aggregate data from its traffic systems, its power grid, its water management, and its public transport. City planners could use this incredible tool to test new policies, plan for emergencies, and find ways to make the city more efficient and sustainable for its citizens. It's this ability to scale from a single part to a complex system of systems that shows the true world-changing scope of this technology. The core concept of digital twins has been around for decades, predating the name itself. It started during NASA's Apollo program with pairing technology. For every spacecraft sent to the moon, an identical ground-based replica was built. This proved critical during Apollo 13. Engineers used the physical twin to diagnose the issue and test solutions. Every procedure was tested on the ground-based twin first. This mirroring technique allowed innovation under pressure, making it the world's first high-stakes digital twin. The principle: use a mirrored replica to understand and solve problems on a remote asset. This laid the groundwork, proving the value of mirrored systems for simulation and problem-solving. The idea of a digital twin may have been born in the space race, but it couldn't truly come to life without key technological breakthroughs. The explosion of the Internet of Things, or IoT, was perhaps the most important ingredient. For a digital twin to be truly alive, it needs a constant stream of real-world data. Artificial intelligence and machine learning enters the picture. They can sift through the noise, identify patterns, detect anomalies, and make predictions based on the incoming data stream. The rise of cloud computing and high-performance computing provided the scalable, on-demand power needed to run these incredibly complex simulations and process the torrent of data. It was the convergence of these four technologies, PLM, IoT, AI, and the cloud, that created the technological tipping point that allowed digital twins to finally move from theory to reality. With the tech in place, the concept got its name. The term digital twin was introduced in 2002 by Dr. Michael Greaves. He presented a model for product lifecycle management. This framework gave the industry a common language, moving it to practical application. Aerospace and industrial machinery were early adopters. Monitoring engine health in real time and predicting failures became possible. This allowed companies to sell outcomes like guaranteed uptime. The automotive industry used twins to design and test cars virtually. In healthcare, personalized digital twins emerged. Smart cities use digital twins to improve traffic and manage energy. Today, integration of AR and VR allows immersive interaction with digital twins. The journey to AI-powered virtual worlds has been incredible. We've covered the what and how. Where is this technology being used today? The aerospace industry uses digital twins extensively. Companies like GE and Rolls-Royce attach hundreds of sensors to their engines. These sensors collect data on temperature, pressure, and vibration. This data is streamed to the engine's digital twin. Real-time monitoring allows them to see how an engine is performing and predict future problems. They can predict when components will need replacement. This allows for proactive maintenance. The entire aircraft can have a digital twin. The same principles are applied to high-speed trains. Sensors monitor the health of critical components. Data is fed into a system that predicts failures and schedules maintenance. This makes the rail network safer and more reliable. Digital twins are revolutionizing healthcare. Imagine a doctor creating a digital twin of your heart using data from MRIs and CT scans. Surgeons could then plan operations and test medications on this virtual model, tailored to your unique physiology. This moves us towards personalized medicine. Zooming out, digital twins are also revolutionizing how we run our cities. Singapore has created Virtual Singapore, a dynamic 3D model of the entire city. Planners use it to test ideas, tackle urban challenges, and make data-driven decisions for a more livable city. Let's shift gears to the world of manufacturing, where digital twins are completely changing how things are made. Modern factories are incredibly complex systems, with robots, conveyor belts, and machinery all working in sync. By creating a digital twin of the entire factory, a company can get a bird's-eye view of everything that's happening in real time. They can see which machines are running, which are idle, and which might be close to breaking down. This is the concept of the smart factory, and digital twins are the brains behind the operation. This virtual factory model allows managers to run simulations to optimize the entire production line. They could ask, what happens if we speed up this conveyor belt? Or what's the most efficient way to retool the line for a new product? They can test these changes in the virtual world first, working out all the kinks without disrupting the actual factory floor. This leads to massive improvements in efficiency, reduced waste, and faster production times. Unilever, for example, uses digital twins in its factories to fine-tune processes, reduce energy consumption, and predict maintenance needs for their equipment. This technology is also critical for managing our energy infrastructure. Take wind farms, for instance. Each massive wind turbine is an expensive, complex piece of machinery operating in a harsh environment. By creating a digital twin for each turbine, energy companies can monitor its health and performance remotely. The twin gets real-time data on wind speed, blade rotation, and gearbox temperature. This allows the system to automatically adjust the pitch of the blades on each turbine to maximize energy capture based on the precise wind conditions at that exact moment. But it goes even further. The digital twin can predict how much power the entire wind farm will generate in the next few hours based on weather forecasts. This is incredibly valuable for grid operators, who need to balance power supply and demand constantly. By having more accurate predictions, they can manage the grid more effectively, integrating renewable energy sources more seamlessly. It's about using a virtual copy to optimize the performance of the real thing, whether it's a single machine, a whole factory, or a critical part of our nation's power supply. Digital twins aren't just for big industries, they're coming to your home. We've had smart devices for years, but they mostly work in isolation. Now, imagine your home with a digital twin, a virtual model connected to every sensor and appliance. This twin learns your routines, like your preferred temperature or when you make coffee. It doesn't just automate, it anticipates. If your fridge's compressor is about to fail, you get a heads up before disaster strikes. The digital twin can optimize energy use, adjust blinds, and even shut off water if a leak is detected. It's not just convenience, it's about safety, efficiency, and peace of mind. Your home becomes proactive, not just reactive. The digital twin acts as the brain, orchestrating everything for a seamless living experience. The smart home is evolving from connected to truly intelligent. Let's get personal. Digital twins are coming to your health and fitness. Wearables already track your steps and sleep, but soon, they'll build a dynamic digital twin of your fitness profile. This model learns how your body responds to different activities and habits. Instead of generic advice, it gives you tailored recommendations, like the perfect workout for your goals. If your sleep drops, it suggests changes based on your recent data. Even your running shoes could have twins tracking wear and telling you when to replace them. It's a feedback loop. Your body, your gear, your habits, all optimized together. The personal digital twin becomes your health coach, guiding you to better choices. Welcome to the era of truly personalized wellness. The next leap for digital twins is AI integration. Early twins mirrored reality, but now AI lets them learn, adapt, and predict with autonomy. AI-powered twins run millions of scenarios, finding optimal solutions faster than any human. In factories, they tweak processes in real time, discovering efficiencies engineers might miss. They're becoming conversational. Ask a question, get an answer and an explanation. These twins don't just predict failures. They can schedule repairs and reroute production automatically. The result? Self-healing, self-optimizing systems that improve on their own. AI turns digital twins into intuitive advisors, not just monitoring tools. This is the future intelligent, autonomous systems transforming every industry. The metaverse is merging with digital twins, creating vast, interconnected virtual worlds. No longer isolated, twins of cities, factories, and supply chains will interact in shared, persistent spaces. Planners and engineers can walk through digital cities, test ideas, and collaborate in real time, no matter where they are. This immersive environment makes complex data intuitive and actionable. Teams can troubleshoot machinery together inside a virtual factory, seeing live data as if they're on site. The metaverse provides the space. Digital twins provide the real-world data. Imagine managing a global shipping network in a living, interactive virtual world. The goal, a dynamic one-to-one digital mirror of our physical world for design, management, and optimization. This is the grand vision, an interconnected metaverse of digital twins. The ultimate frontier is the human digital twin, a complete real-time virtual model of you. It integrates your genetics, biology, and daily habits, constantly updated by wearables and health monitors. Doctors could test treatments on your twin, finding the best option before you ever take a pill. It's the end of one-size-fits-all medicine. Healthcare becomes hyper-personalized. Your twin could simulate the long-term effects of diets or exercise, guiding your choices for lifelong wellness. But this raises big questions. Who owns your data? How is it protected? The potential to prevent disease and extend life is huge, but we must address the ethics. The human digital twin could be the most impactful innovation of our time. We've explored the world of digital twins, from their NASA origins to today's AI-powered systems. They're not just 3D models, but living, evolving replicas, transforming industries from aviation to city planning. Digital twins optimize factories, predict maintenance, and help design smarter cities. This isn't science fiction, it's happening now, quietly powering our world. The future is interconnected. Twins of machines, systems, and even people, forming the backbone of the industrial metaverse. The human digital twin could revolutionize medicine, offering personalized care and longer, healthier lives. Digital twins bridge the gap between physical and digital, creating a two-way conversation. This feedback loop is the secret sauce, constantly improving our world. As the tech gets smarter and cheaper, it'll touch every part of our lives. The mirror world is here, and we're only beginning to see its potential. That wraps up our dive into digital twins. It's rewriting the rules of engineering, medicine, and urban planning. From keeping planes in the air to designing smart cities, digital twins are the invisible architecture of the future. I hope you now have a clear picture of what they are and why they matter. If you enjoyed this, subscribe to keep learning about the tech shaping our future. Ring the notification bell to be the first to know when we drop new content. Drop a comment and let me know your thoughts. Thank you for spending part of your day with Tech Curiosity Stream. We've got more deep dives coming soon, so be on the lookout. See you in the next video. Until then, stay curious.